we will get started with some introductions. So we have a few students and a few faculty members joining us. So I'll ask the students to introduce themselves. So if you can tell us your name, your program, and for our students, if you can tell us about a course that you're taking right now, that's really exciting. And for our faculty members, a course that you're teaching, unless you're taking one as well. So let's start off with Rhythm.
Hi everyone, my name is Rhythm. I'm in my final year of Earth and Atmospheric Science with a specialized honor in Atmospheric Science. And this semester, I think the most interesting course I am taking has to be cloud physics. And basically the entire point of the course is to understand how clouds are actually formed and all of the math and physics that goes behind it.
Michele?
Hi, I'm Michele. I'm a second-year space engineering student. My favorite course right now would probably be my SolidWorks course, where we're learning how to 3D print and model. It's a really interesting course where they're teaching us a lot, starting from the very basics of I don't even have the software downloaded to I can now make stuff, which is pretty cool.
Excellent, thank you. Professor Newland.
Hi, I'm Franz. I'm undergraduate program director for space engineering. My course that I'll talk about is a course that we're going to be doing in the winter, where we take our second year space engineering students doing space systems engineering and our fourth year students doing space mission design, and we mash them together and we design space missions and the systems that go on them. So that's always an exciting course to do, where we combine our second and fourth years together to have a really holistic view at the whole mission.
Excellent. Professor Bisnath?
Hi, I'm Bisnath. I'm a professor of Geomatics Engineering. I'd have to say my favorite course that I teach is a course on GPS. It's a unique thing to have an entire course on how this particular satellite navigation technology works. And so we talk about why GPS, how a receiver works, how we make measurements from it, and the wide variety of applications that we use it for, from your smartphone to millimeter level positioning for determining how the tectonic plates move. So all kinds of ways that it affects our lives.
Thank you. And Professor Chandan, who is joining us with our youngest attendee.
Yeah, so in addition to babysitting my 6-month-old, I also teach a course on climate and climate change, and that's I really enjoy for a few reasons, because it's my area of research, and also because students come to the course having seen a lot of things in the popular press or in their own reading about climate and climate change, and they're trying to sort out their own thoughts about it and trying to really dig into the processes. So we get to bring in not just my thoughts from my own research, very current frontier problems, but also toss around the ideas that they bring to the course. So I had a student from civil engineering who was very interested in green roofs and various ways of mitigating climate change. And I had no students like that in my previous year course. So he had an impact on the course, how we taught. Every student that comes into the course has an impact on how it's taught. And so it ends up being very fresh and new every time we go through the course.
Thank you everyone for those introductions and sharing a little bit about your learning and teaching journeys. So we have one of our students here, Denis, who will be monitoring the chat for any questions, and feel free to nudge me if you see any. Again, to our future students who are joining us, this is really your opportunity to ask any questions that you have in mind. We do have a few questions lined up from our previous session, but that we've received from future students over time. But you know, every student is unique, and your questions would be unique too. So please don't hesitate asking what you have in mind. So I'll start with one of the common questions that we get around space engineering, Professor Newland. A lot of times students are looking at space engineering and aerospace engineering programs. If you can help us understand the difference between the two, that would be great.
Absolutely. So In aerospace engineering, you look at things like mechanics of flight, air-breathing engines, aerodynamics. In the space engineering program, we don't cover those things. We do cover the electronics that you would see for aircraft as well. We cover control, we cover mechanics, because that's important for structures for both space and in the atmosphere. But what we gain as a result of not doing some of those aero pieces is we gain more space to think about two aspects. So our space engineering program focuses on systems engineering. So how do we integrate all the things you need to do to put into a spacecraft, mechanical, electrical, software, navigation, and also thinking about the environment that you have to build it for. And then the other thing that we focus in on is payload engineering. So how do we understand the world around us, and how do we engineer things that interact with that scientific understanding of the world around us that we can then put on our spacecraft to sense both, you know, the Earth and space. So those are some of the key differences.
All right. Excellent. Yes, I know that a lot of universities offer aerospace engineering, and we're unique where we offer space engineering, not only in terms of offering, but also what's taught. So it's important for students to understand the differences between the two as they're making that selection.
Yeah, we are in fact Canada's only space-only engineering program, so we get to go deep into those aspects as a result. But again, it's important to recognize, you know, this is an opportunity to explore those exciting ways. But an undergraduate degree is really about opening different doors. So if you're excited about space and wondering where to go next, the good thing about the space program is it doesn't prevent you from going in an aerospace direction at the end of the day, or a mechanical direction, or an electrical direction, or any of those, because the undergraduate degree is the starting point of this long journey that you go on afterwards.
All right, so I'll switch over to Professor Bisnath for the next few minutes. You mentioned that we have an entire course on GPS, and that's exciting because we have so many tools around us that rely on geomatics. But myself, you know, my colleagues and our students who are joining us might not realize how integrated geomatics is into our lives. Can you speak a little more about what some of those things might be?
Sure. You know, geomatics was what we'd call the old surveying and mapping engineering. It was a branch of civil engineering, but it just got so specialized we spun off. And most of it had to do with sensors and technologies and programming. So you can imagine geomatics as something of a hybrid between old parts of civil and computer science. So what we deal with really is spatial information, which is what we all use every day. So everything from having that pizza delivered to your home, to your car navigation system, to figuring out where your phone is. You imagine those things. We interact with them every day in a myriad of ways. So what we focus on is collecting that kind of spatial information, and showing it, you know, in digital maps and 2D, 3D, virtual reality, and being able to measure on it and make decisions on it. And the decision making is really where the money is, because it saves us time, or it allows us to make a better decision. And that kind of technology just is rapidly advancing. So if you imagine 3D building models where we're doing design and everything from landscaping to, you know, the air duct systems and how air moves along, we need the basic models. So geomatics has evolved there. Where we're heading with so much of the work is what are called digital twins. That is, whether it's a road, a building, or an entire city, building a digital twin of that city. And how do you do that? So we use a lot of different sensors, whether it's GPS for positioning, LiDAR for laser scanning, all of these things to put them together to build digital twin models that we can virtually do design on. And that goes beyond geomatics. That brings in all areas of applied science and engineering. So they're building all of these constructs to allow us to safely or more economically develop. So we call this part of sort of the next engineering or the next industrial revolution.
Thank you. Thanks for sharing that perspective and how there are so many applications, not only current, but even future developments that we don't think that rely on geomatics engineering or geomatic science. And next question is for Professor Tandon, and then I think Dennis has a couple of questions for our students. So Professor Tandon, climate and climate change is forefront on the news, and a lot of times it comes across as a big challenge, a big task, something that needs to be done collectively. But closer to ground, when students are in this program learning about the atmosphere, what are some things, tools or courses that they might learn that will get them started on that journey to learn more about climate change and having an impact there?
Well, yeah, you can't, like you say, it's an immensely challenging problem, and you can't attempt to tackle it with any single tool. My tool of choice tends to be using climate models, but I fully acknowledge the fact that you can't solve everything with climate models. You need people who get out there and take the measurements that based on which we will decide what sort of actions we need to take. We need the people like Professor Bisnath and people like Professor Newland who launch satellites into space and get new measurements about characteristics of the atmosphere that we can't fully characterize right now. So there are various aspects of, say, convection and its behavior and its coupling to large-scale features of the atmospheric circulation that still remain to be understood, and there are missions that we're launching now that are attempting to understand that. And then there's satellites that get a few years of information, and there's a failure in the satellite, and we need to launch a new satellite and get continuity of these data. And so we need all these people from different disciplines to come together and take a multi-pronged approach to these things. And then you have people on the engineering side who think about ways of drawing down carbon in the atmosphere, either through ways of scattering of materials on farmland or through carbon capture devices. And that's where there's some interesting collaboration going on with civil engineering. And so as a student in this program, you have access to all these different tools, and you'll be learning about the geomatics that goes into getting the information. You'll be learning about the satellite systems that are needed as the backbone, the hardware for capturing this information. And in my course, you'll be learning about the modeling side as well. So you'll come out of this program with an appreciation of these tools, and also with hopefully some clarity as to what aspect of this you would like to focus on in your future journey and contributing to tackling the problem of climate change.
Thank you for sharing that. All right, I'm going to pass on the mic to Denis for a bit. I see you have a couple of questions for our students.
So I'm gonna probably bother Michele first with this, then I'll go to Rhythm. But Michele, as a space engineer, how did you know that you wanted to go into space engineering? Did you maybe know in grade 12 you already wanted to do it, or did you bounce around between a few programs and sort of landed here?
Great question, Dennis. I actually had absolutely no idea what I wanted to do in grade 12 and was a clueless mess. It was amazing. I had my heart set during grade 12 first semester on going into business. I really liked accounting. And halfway through second semester, I kind of realized that you don't always want to go and study something just because you're good at it. Sometimes you have to follow your passions, even if it's not your best subject. And that's kind of what brought me towards engineering. It's just I wasn't as strong as an engineering type student rather than a business student, but I really knew I really loved it. And if I put my heart towards it, that's what I would have wanted to do anyways. So in that sense, I did decide to go into engineering with that. As per choosing York specifically, I really liked the concept of space engineering. It sounded interesting. And I knew that even if I didn't like it, I would still end up with a bachelor's of engineering. So I'd still be okay to get a job afterwards. So that's kind of what brought me here.
Before I go to the rhythm, actually, there was a question in the chat that I wanted to address first. This will be to Professor Newland. How many space engineering graduates are there in activity? Obviously, it's probably going to be a little different this year, but about on average in a regular year.
Yeah, so it's a great question. So I think one of the interesting things with all the programs in our department is they are smaller programs focused on important areas that are often sort of a deep niche that the market needs and so on. So with space engineering, in our lower level courses, we typically have between 25 and 30 students in our courses. In our graduate year, because we have students who go out into co-op, so that'll spread things out, but it's closer to that 15 to 20 students in a typical final year course and then graduating. So that's the numbers that we currently have. So it's a program that has people who are like Michele, perhaps weren't initially sure what they were going to do, but when they get into the program, they get really excited about that. And I think that would be true for our other programs in our department, that they're the programs that students are very tight knit in our programs and get the chance to work together very closely.
Thank you, Professor. Now I wanted to go back to rhythm actually with the question that we asked Michele first. Didn't want to single anybody out, but how did you know you wanted to go into Earth and Atmospheric Science?
I didn't at all. My entire plan in grade 12 was, I'm going to do geomatics engineering. That sounds so cool. And then after, when I actually came to the open houses and I talked to like the different faculties, and I always kind of had a little bit of passion about climate change or like interest in climate change and how weather phenomena work because they're so interesting, right? So when I actually ended up coming to open houses and I talked to everyone, what really like caught my eye was when I talked to the York Atmospheric Science Club, and they were talking about how they take a specific course on climate change and how they talk about the processes that go into weather. And I was like, you know what, at the end of the day, sure, geomatics sounds cool, but like weather has always been like a little passion of mine. I have like books on books on books about it when I used to read them. So I decided to go into that, and I don't regret a single thing.
Thanks. Now we have another question in the chat. This is also for Professor Newland. What kind of jobs or career paths have you seen space engineering graduates go into?
So again, what I'll say about any undergraduate degree in engineering or applied science is that it's about opening doors rather than closing them. So if you do a degree in space engineering, you've got to think those systems engineering and payload engineering skills are relevant to so many different disciplines. So it could be that you've come into space engineering passionate about space, and there are lots of opportunities in the space field. In Ontario alone, there are about 80 different entities that do something to do with space. A lot of them are fairly small. There are some bigger companies as well. But so across Canada, there is a very important space activity. It's we punch well above our weight in terms of the amount of money that goes into it. But in terms of other places that our graduates go into, so in the space field, we have students that have gone into places like MDA. We've had students go overseas working for space companies in Europe and elsewhere. But thinking about the broader field with a systems and payload background, that can lead to fields in other areas of engineering. It could equally lead to other areas like financial engineering and financial world because of those skills that allow you to integrate knowledge across many different areas. So again, think about the undergraduate degree as a chance to learn how to learn what you're going to need afterwards. But it's not closing doors to other opportunities. So we have a good rate of, very good rates of graduate employment across all our programs in the department. And that really talks to the fact that an undergraduate degree in any of these fields is really giving you the opportunity to open many doors. I hope that answers the question, but feel free to add anything in the chat if you want to follow up.
Thank you, Professor. And that was a good point too, mentioning that it is also very multidisciplinary, and that if you go into one specific field, you're not just stuck there, that you're welcome to venture out and sort of mesh into other fields too. Now I actually have a question for a geomatics professor. Professor Snell, how did you know that you wanted to go into geomatics engineering and that was your passion, and specifically geomatics engineering and not perhaps something else?
Well, I think unlike rhythm, I didn't know that I wanted to go to geomatics. Sorry we lost you, rhythm, but no, it was the strangest thing. I had a university recruiter come to my university. I knew that I wanted to, I was definitely heading into, the applied sciences rather than pure sciences. And the recruiter said, hey, well, here's something interesting. There's a bright future. There are a lot of jobs in the area. And I said, okay, well, let me look into it. And they were talking about technologies that I hadn't heard of. And I'm getting pretty old, so this was a long time ago. So when they mentioned things such as digital maps, we hadn't really ever heard of a digital map. Maps were all paper. Boy, it makes me sound really old. And then they mentioned this acronym that nobody had ever heard of called GPS, and they were really exciting. Today, when we talk about new things like BIM and digital twins, almost certainly, in years to come, these will just be standard terms that even little kids will be playing video games with. The same as the idea of an autonomous vehicle. We talk about these things, but they will become, our realities at some point, not, in the future. So, yeah, I heard about it from a high school, from a university recruiter, and there was just a lot of interesting technology, and it was new and it was different, and it continues to be that way.
Thank you, Professor. Yeah, definitely opening up a large paper map and trying to find your way is not only a way of the past, but also terrifying. Mudita, were there possibly any other questions that you wanted to ask?
Yes, so Professor Bisnath and Professor Tandon, you both mentioned computer modeling, one for the climate, the other one around in the context of geomatics. So with computer modeling or making 3D models or even VR models requires some computing. So usually when our future students are looking at a university program, specifically Earth and Atmospheric Science or Geomatics, they might not be making the connection of how computer science or any programming fits into that. So one, if you can share a little bit about how some programming is relevant to both these fields, and also if they don't have any programming experience in high school right now, what should they expect in first year? Professor Tandon, if you can get us started.
Yeah, sure. So imagine being actually a lot older than Professor Bisnath, and if you wanted to do a calculation of, let's say, wind velocity in the atmosphere, instead of just clicking on a link, downloading and running it through a Python or a MATLAB program, you actually had to transcribe it, take out your abacus and start doing all sorts of calculations of temperature gradients and things like that to infer what the wind was. That would be a nightmare. And I would say, if you're afraid of programming, just compare to what the alternative is. instead of, you learn a few lines of programming and you can get that sort of task done in a fraction of a second. It's amazingly powerful what you can do if you go through that initial effort. If you struggle with programming and get through that initial effort of your introductory courses and learn some of those tools, I guarantee you, coming out of that, you'll realize the power of that, and you'll feel like you have a leg up on other people because of that. And it's not just for data analysis. If all the models used in climate and weather forecasting are written in Fortran. And that can be scary for some students as well. But I guess to allay some of that concern is the fact that you typically won't be trying to write a model completely from scratch yourself. I tend to take, it tends to be more of like a hacking approach that you might take to improving these models. You look at the code and you say, okay, how can I make this work a little better? How can I make some of the physics a little more realistic? And you start adding code to it. And that's why these models are written in Fortran, is because no one's bothered to rewrite them from scratch. They inherit the code from their elders, and that goes back to the 70s when Fortran was the code of choice. And you can hack these codes, in which case you can look at the code and learn by example, and start doing some fun things with them.
Yeah, to follow on what Neil said, our geomatic students, they tend to fall into sort of two categories. One is a practitioner, someone who practices something when they're done. So for example, many of our students go out and become land surveyors and work at land surveying or engineering firms. Others become GIS specialists, so they work with the digital maps. Every day. And then others are more developers. So they will go on to develop applications for these fields, or they will go on to grad school, or they will work for other companies where they're using these specializations. So for us, I wouldn't say necessarily computer science, but coding, which is not going through all the rigor of computer science, but making use of computing is, it's kind of like math or physics or writing. It's a necessity. So computing is part and parcel of the program from first year, where you're taking specific computer science courses that all the engineering and computer science students take, all the way through to the fourth year courses that in most of the labs have a computing course component. That's the language of how we do our work. So yes, you learn a lot of math, but how do we use it? Well, we apply it in coding. So it's a language and a medium of how the work's done, whether it's for the practitioner or for the developer. And at the grad level, at the research level, where a lot of this work goes, it's just part and parcel of the work, the same way as Professor Tandon described it in many languages, whether it's C, C++, MATLAB, Python, and the list goes on. So, and at that point, there's a lot of integration where, we have physicists and, geomatics engineers, space engineers, software engineers, electrical engineers, computer engineers, all working together on much more complex problems. So we bring together a lot of people, but computing is just part and parcel of the modern way that we work. So there's a lot of coding from the beginning to the end.
Thanks, Professor Bisnath. That was a really great way of understanding the computing or programming as being a tool, a language, or a medium of doing things. And I'll keep you on the mic and ask everyone, you work with students in a capacity that's broader than teaching in a course. You might be mentoring them, be involved in research with them, or be part of a student club. So I just want to hear from everyone here, what is one other way to enhance your learning and your student life outside of your program? So Professor Bisnath, if you can get us started, and I'll ask our profs and our students their view on this as well.
Wow. Okay, that's a tough question in a way. You have me started. So the question is really, what are ways outside of the university that we?
I would say specifically outside of the classroom, how do you see students enhancing their learning?
Yeah, people hear this a lot, but it's true, and that's why we hear these things a lot. But the imagination, the whole thinking outside the box, critical thinking. I've had students that I've taught from around the world, and it's quite interesting the different cultures that we have, whether it's within the city of Toronto or Canada or globally. And one thing that I remember a student said to me years ago was, a professor, where I come from, all the exam questions start with what is this, what is that, definitions, and your questions sort of always start with why are we this, why this, and they found it very difficult because it's not rote learning. And I think that's what engineering's about. That's what applied science is about. It's really what I think Lassonde is about. And so how do you do that? It's difficult. If you're used to just memorizing things, how do you apply them? And how do you think beyond that? How do we connect dots? And then how do we go beyond connecting dots to extrapolating when there aren't dots? So it's important for students to do other things outside of school. And it comes from their imagination, spending time in nature, even playing video games. And I have to say they pretty much all do that. Watching movies or finding inspiration in other things. Examples where students come back and say, I saw this sci-fi movie and they were doing this. Is that possible? Could we ever do this? And a lot of times the answer is, you know what, we already do that. It's just that we can't do it that way. We can't do it in that Hollywood way. So imagination, it's so much about, creativity, imagination, and the critical thinking and thinking outside the box. All of that comes from it. And it's tough because when you're learning a huge amount of material, sometimes it's hard to find the time to think beyond that. So yeah, that's my bad attempt at answering a really good question.
No, that's a fantastic attempt. I love the why. So that's great. Professor Nealon?
Yeah, so I'm lucky enough to get to engage with a number of our students in various club activities and so on. Whether it's Engineers Without Borders, and you think, well, that's often associated with mechanical or civil engineering, but what fewer borders do you have than going into space? So thinking about ways that you want to have impact on the world. Often we find our students think about those types of questions outside the class and they bring them into the class, which is an exciting thing to think about. There's opportunities for getting engaged with clubs within a different discipline. And, Rhythm, you were saying earlier on about the Earth and Atmospheric Science Club, the Atmospheric Science Club. And in space, we have a rover team, and we have a rocketry group, and we have a group of undergrad students working on our second CubeSat. We've just launched our first, and they're going for the second. So there are clubs like that where in the first year, where we have a common first year, you get the chance to maybe engage in some of those clubs and get a feel for what types of things you're excited about. And if you sign up for the engineering program in the first year, you have that first year to think about which is the journey of engineering that you're going to be most excited about for the remainder of your program. If you're in the science streams, there are ways to think about different avenues after your first year. I played in my jazz band and wind orchestra when I was doing my studies, and music is a really important part of who I am, and finding outlets for being all of you and bringing those from outside the classroom into the classroom is really engaging. So we have opportunities for engineering and non-engineering students to do. We had a music maker fair a couple of years ago where we had some music students working with engineers, building musical instruments and then composing for them. And this was a chance to sort of bring those worlds together. So finding the spaces where you can really be you and understand the learning that you're going through, but also the impact you want to have on the world at the end of it. I think some of the things that you get out of those types of experience.
Thanks. Professor Tandon, your take?
Yeah, so I would echo things that Professor Bisnath and Professor Newland had said, namely keeping a creative outlet of some sort. You're not going to solve interesting problems in science or engineering by just repeating what people have done over the last 20 years. They're immensely challenging problems that require a lot of creativity. And so keeping your creative muscles alive in the arts. I happen to do it through music, just like Professor Newland does. I'm a bass player. And you'll find that by doing that, it yields benefits. You can get a break just from the tedium and the stress of work. And relieving that stress will make you better when you go back to thinking about science and engineering problems. And also just the exercise of your creativity will directly translate into being more creative in science and engineering. And then more specifically for our program, as Professor Newland mentioned and Rhythm mentioned as well, the York Atmospheric Science Club. If you end up going into the Earth and Atmospheric Science program, I strongly encourage you to join that club. And you'll really enjoy the benefits of that community of supporting each other and talking to your upperclassmen. Chances are, if you're encountering a problem, they've encountered the problem as well, and they can give you advice as to how to navigate it. And also, they just engage in a bunch of fun activities too, like the Weather X challenge, and I know there have been students in the past that construct their own weather stations too. So the weather nerds among you will find camaraderie there as well.
Thanks, Professor Tandon. And I believe Denis has one last question for our students, and then I'll wrap up. Also a reminder to anyone who's joining us, if you have any pending questions, now's the time.
Yeah, so Professor Tandon was mentioning about having a creative outlet and sort of doing things outside of class that can help you relax and take the stress off of other things. So Rhythm, this one's to you first. What is your creative outlet? Even though we've got a pandemic running on now, what is the things that you do to let you de-stress from work?
So I'm actually going to combine both of those questions, the one that Multidisciplinary asked and the one that you asked. So for me, my creative outlet has to be dance, just something that's completely out of what I'm doing. I know my name's Rhythm, it makes sense, but like we're going to move across that. We're going to move on from that. But like one thing I did want to mention, like I am the VP of the York Atmospheric Science Club. And the one thing that I love about Lassonde is the fact that we have learning outside of the classroom. And that's very important because inside the classroom, we might be learning very theoretical stuff. So part of like the Atmospheric Science Club, what we try to do is we try to apply it. So we have weekly, weather discussions with Environment Canada, where we actually like analyze different weather phenomena that have happened and how they happen and things like that. And then we have the weather challenge. And that really gives you an aspect of just, sure, you're learning this in class, but there's that creative outlet to actually apply what you're learning. So yeah, sorry, I wanted to combine both of them because I wanted to say a little bit.
Oh, that was great. Thank you, Rhythm. Okay, this is probably going to be the last question unless anybody else puts any in the chat. But Michele, what is your creative outlet?
So unlike everyone here, I am not creative artistically at all. I can draw a little bit, but that's about as far as that goes. I have a huge creative outlet within sports and recreation and anything athletic. So I'm actually a varsity athlete at the university on the women's field hockey team here. So exercise, exercise, and more exercise is pretty much what I do. Our team trains a lot. So you'll be seeing me on the field a lot. You'll be seeing me in the gym a lot. I'm just always trying to stay active. I find it's a good way to de-stress. It calms your nerves, and it's also good for you. You're getting exercise. You sit at your desk because you've got like 6 courses a day and you're just writing and doing all this work. It's really good to actually get up, stretch, go for a run or walk if you don't like running, or just, you know, do some weights. It's just a really fun environment for me for that sense. And just it's a good environment to get to like communicate with other people, because I have a lot of good teammates and I made a lot of friends within the varsity community. Of course, I have friends in the engineering community too, but it's good to have friends outside of just your one core group. And I've been able to have that outlet within the varsity community.
It's definitely good to communicate even during a lockdown quarantine. Mundira, did you have any final notes?
No, I'm just thanking all the current students and profs and future students for joining us. The only thing maybe I can ask is, you know, Michele and Rhythm, you were in the shoes of our future students not too long ago. So as we wrap up, if Michele, will start with you, if you have any piece of advice that to sort of support our future students, that'd be great.
Yeah. So one thing that I would really take to heart is that, or I really wish someone would say this to me when I was in your shoes, is that as you're looking at all these universities, and it seems like it's a very overwhelming decision because there's so many factors like, oh, how much money it costs, am I going away, am I staying here, what program? There's so many questions that you have to be asked. Make the decision for yourself. As much as you want to hear your peers, their opinion on it, your parents' opinion on it, the end of the day, this is what you're going to do with what you want to do with your life career-wise. And no one can tell you what's going to make you happy. So my piece of advice would definitely be to make sure you go into something that you want to do rather than just something that is like, looks like your parents want you to do or something like that. So yeah.
I'm going to continue. My piece of advice would be take the next 6 months or so to figure out how you learn. Because when you transition into university, yes, the course load can get a bit much and everything does happen at a faster pace. So if you have the skills prior to that, where you know how to, work through problems, whether it's drawing pictures, repetition, whatever it is, if you have those skills already, it will make your transition a little bit easier. Whereas like someone who might be just doing trying a bunch of different study techniques can get lost in the process.
Thank you both for sharing those tips. And I'll be wrapping up our session as we are at time. Just to keep in mind that, we had our session for our 3 programs, Earth and Atmospheric Science, Geomatics Engineering, Space Engineering. Today, we do have 2 more sessions coming up. Tomorrow is Mechanical Engineering and day after is Civil. But this is not the only time that you get to chat with us. So if you have more questions about atmospheric science, geomatics engineering or science or space engineering, please feel free to reply to any of the emails that you've received. Our faculty members and our student team is very responsive. We'll be happy to connect you and find more information for you as you make this very important transition from school or another college to our program here at Lassonde. Thank you again, everyone, for joining us, and we'll catch you in the next session.